Okay, in this exercise, we're going to cover some of the basics of surface creation and surface construction with some parametric control. And we'll also talk a bit about subdividing surfaces, some of the basics of that, so that you can add more detail to those surfaces, maybe architectural components. Um, but in any case, what we'll do is we'll just sort of introduce some of the basics, so we're kind of moving from 2D drawing of curves and into kind of using points, curves, and lines to construct surfaces in 3D. Some of this was covered a little bit before when we covered these tutorials. In particular, the Smithsonian, the Skynet, Waterloo Station, and London City Hall, and also a bit with the S Hotel. So, but as a preamble to that, I thought it'd be useful to kind of like walk through some of the more, maybe go a little slower, walk through some of the basics of the setup of these as a way to, again, kind of inform these case study tutorials that some of you watched last semester. So we're going to start from scratch here. We won't use for this exercise any Rhino work. We'll just get going right away with some basic grasshopper geometry. So we'll start first with the vector tab, and we'll head over to construct point. So I'm going to start everything with a single point, and I like to start it with an x and y just a little bit beyond the 0, 0, just so I can kind of see it a little bit away from our x and y grid axes in the Rhino viewport. And what we're going to do from this point is draw a line. So I'm going to head over to curve, and in the primitive box here I'm going to find line SDL, and I'm just going to draw that. By default it's going to draw a little line up in the z direction, because by default the direction here is set to the positive z vector, but instead I'm going to go over to vector here and grab my unit x. So move that in the x direction, and then I can just set a length, so I'll just double click in here and build up a slider between 1 and 50, and I'll just kind of move that all the way up so that we have a line of 50 units long, starting with the 2, 2, 0 as a starting point in the Rhino world. Now what we're going to do is we're going to use this line to define out in space a set of points on either side of it that I could use to start drawing some cross-section curves for a larger surface that I'll build along the length of that line. So one thing to introduce here, we won't use it for this exercise necessarily, but one thing I want to introduce just as a way to kind of just demonstrate how you might find a point along the curve. You can go over to curve and grab this evaluate curve component, and then just grab a default slider from your parameters tab. And because this curve is already drawn in Grasshopper, it's already parameterized between 0 and 1. So that means as I drag this slider across between the 0 point and the 1 point, if you will, that'll kind of define the endpoints respectively, and anything in between that 0 and 1 as a location along the line will be shown here. So 0.5 will be the midpoint, and so on. So this is the basic parameterization of a curve. We won't use this for this particular exercise, but I thought it was relevant here because what we're looking to do is find locations along this curve that will determine the construction of, again, a set of cross sections that we'll use to create a surface. And for this sake, I'm going to turn off the original point here, just turn off that preview and just see the line as it is. And then I'm going to head up to curve, division, and divide curve. And by default this will divide 10 times into 10 segments, so 11 points. And this is something you're all familiar with, so I won't talk much about it, but I'll head over into the input panel here and just kind of put in, just going to turn this basically into two segments overall, which will give me 3 points, so it'll give me the start, the end, and the middle. So it's a kind of a quick way to do that. There are a variety of ways to do this, and you're welcome to use whatever version is most comfortable to you, so long as the points that you get out of it are in some kind of order that you can remember later. In this case, it's first, second, third. Okay, So what I'm going to do now is take these points and move them to one side of the line and move them to the other side of the line so that they're equidistant from each other, so that basically this line becomes a center line between the two sets. Alright, so I'm just going to head over to translate and Euclidean and move. I'm just going to go ahead and pop those points in like this, and you can see by default that it is already set to a translation vector of 10 units in the z direction. That, of course, we don't want. We're going to set this instead to the y direction, so I'm just going to double click in here and just type in y, and my unit y vector will pop up for me right away. You can also find that in the vector tab and the vector box here, unit y. So go ahead then, let's create a slider again, this time between, let's say, 0 and 20. Okay. And now we can just plug that in and kind of reset basically the translation vector that this component is set to. And now as I move this slider around, you can see the points moving in the proper direction, which is basically in plane with that curve in the XY plane. Because again, I'm kind of set up some points, basically some anchor points that I could use later along the ground plane, if you will. But what I want though is a mirroring basically of those lines across the other direction too, in the negative y. So again, variety of ways to do this, but one way to do it is to just simply copy and paste this component out and then reverse the y vector. So we can head over to the vector box over here on the right and just reverse that. So this is going to reverse that direction to keep the same amplitude. And we can use one slider basically now to control, 2 sets of points basically, or 6 total. Now if I wanted to have more control over this, if I wanted to, let's say, move the middle ones differently than the ends, and this end differently than this end, what I have to do is basically I have to input more of these, and I have to be able to control each one of these points individually. So let's go ahead and copy and paste this slider a couple times. Okay. And then we're going to head over to sets, and we're going to grab over in tree over here on the right our merge component, somewhere in the middle there, and just start merging those 3 those 3 sliders into one component here, like so. Give me a little bit of breathing room here. Now I should be able to just swap that in. Now if you can take a look at the data, we've got three results coming out of one component, and those 3 results are coming in to set 3 move vectors, 3 translation vectors, which are nicely aligned with the 3 pieces of geometry that we have coming out of the move component. Right, so 3 for 3 basically. And now if I take a look at this, I can move those middle ones independently than the outer ends. Okay. I'll just leave that at like something like this, 7, 7, and 16. Okay, so let's define something now to draw with these points. What are we going to construct? Well, just for the sake of simplicity here in this exercise, we'll just kind of draw an arc. So I'll go to the curve tab here and I'll find there's a couple different ways to draw arcs. You can see down here. I'm going to grab this one in the middle here, arc SED. This way we can continue to introduce vectors. And the start point I'm going to want to set to this set down here. And we'll talk about that in just a second. So I'm going to set the start and end point like this, kind of cross those wires. And then as my tangent direction, I'm just going to, for now, I'm just going to pop it as Z. So I'm going to head over to vector and just pop in the unit Z direction here. And you'll see that a few arcs get drawn that are basically semicircles or half circles, because the vector that sets the angle of the arc is directly up in space, right? Directly vertical. And that's going to create a tangent arc as a semicircle. So we can control that. In this case, the control that we have over this arc shape is really based on the angle of the direction input here. Okay, so what we need to do is kind of pop in something here that allows us to rotate that. Now you can do this, you can rotate the Z here, and you can take it from 90, and you can subtract from that, take it down to 0. I'll do it in a slightly different way, just for the sake of variety in the script here, so I'll go with the unit Y instead. And my rotation axis is going to be the x-axis, so I'm going to go ahead and grab one of those as well. And now in that same area over here in the vector tab, I can find this rotate component. This is going to rotate vectors for us. The vectors that we're rotating is going to be the y, and the axis will be the z, the x. I can actually delete the z here. The angle then is going to be set as a slider for us, but by default this is going to be set to radians. I typically like to work in degrees, so I'm going to right click on that and just click degrees here to set my input to translating basically a rotation value to degrees, which is a little bit more straightforward maybe. And I'm going to set a slider here now between 0 and 90. And I'm just going to throw that in there like this. And then I'll go ahead and throw that into the D input here, and when it's set to 0, the line will look straight, and this component will stay orange, because actually you can't really draw an arc that's flat. Technically it's just a line. So actually if we set this thing higher than 0, you can see that we will start actually lifting that arc into either a semicircle or anywhere in between a line and that. Okay. Now again, similar to what we did before, we can change the angles of all of these independently if we just use a merge component. So I'll double click, just write in merge, and then I'll copy and paste a couple more sliders here, and I'll put those in so that we have 3 inputs, and I can just swap those in, and I'll clean up a little bit here, and then you can see that I can now modify those independently from one another. And that will have some small effect on, well, actually in some cases a large effect on the result that we get out of the next step, which would be to kind of loft this stuff together. So I'm going to treat all these for now with the same angle. Maybe I'll set them all to 65. So you can kind of just double click in there and set those to be standardized for now. And now what the output of this is 3 arcs that are in line with one another. They're in order of the points that were drawn originally, so we know that that could work for a loft, because the component can kind of read 1, 2, and 3 in a sequence. So I'll head over to surface here, and I'll draw a loft surface with these, and I'll just input those arcs straight in. Okay, so what we've drawn basically is this sort of beetle-like shell, or this kind of vaulted-like surface, and it gives me a few different points of control. I have some control over the shape of it in the middle, right, the center cross section. I've got some control over its outer cross sections. Right, so if I wanted it to be flat and kind of saddle-like, I can do that if I'd like, no problem. I can also quickly modify it back to being more dome-like. I can also go back in time a little bit here, and I can make some adjustments to its overall kind of outer profile, if you will, those kind of outer edges that set its width both at the center and also at the 2 ends. Okay, so this is just again an example for how you could use a relatively straightforward setup here, just a simple geometric construction that allows for you some control over the surface. Now remember that how you do this is entirely up to you, and it's your strategy, and it depends on what you'd like to get out of the surface in the end. So as a designer, you'll have to make a call as to how you set up your file so that either yourself or others can use it to produce the kind of output that you want. Into a kind of a range of solutions space, basically a kind of an area within which the work can be modified, but not too far, so that you still have some evaluative criteria. And here we have a pretty constricted set of inputs that still allow for quite a wide range of variety, so long as you follow the dependencies. And the way that this is set up is that this surface is all the way downstream, and it's dependent on all the rest here. Okay, so at any given point I can make changes to any of these inputs. I can move it. I can change its length overall. I could vary its cross sections, and I can vary basically the height of those cross sections. And I can do all that independently. One thing you can also do is begin sharing. You can start developing relationships between these sliders really simply, right? So you can say something that let's say as this gets longer or shorter, something else is affected down the line. And we already talked in previous exercises about remapping values, and potentially even adding and subtracting, or even just setting, one slider to do two things. So that's something you could experiment with. Again, as you get used to working this way, you could start to really develop kind of really tightly controlled solution sets, so that your users or yourself could, can have a good amount of control, but also kind of make quick updates, within the bounds of any kind of design project and the specifics that you're working toward. Okay, so I'm gonna this is gonna be kind of part one here. So we just covered some, basically reintroducing some tools, maybe introducing a couple more, and really just kind of introducing the topic of controlling surfaces with some level of parametric construction. Okay, so we'll head on off now into the next part, which will be to add a little bit of more control over this using a different surfacing option.